So children, to understand what makes electric current flow through wire, what is electricity? First, let's understand a few basic concepts. To understand what is potential difference. If you can see on the board, the first figure drawn consists of two beakers. Now, in these two beakers, we can see that the quantity of water in both the beakers is the same. The level of water in both the beakers is the same, as well as the two beakers are connected at the bottom with a pipe. Now, the question over here is, will water flow from beaker 1 to beaker 2? Or will it flow from beaker 2 to beaker 1? The answer is no. From none of the beakers will water flow to the other. Why? Because both the beakers are at the same level, kept at the same surface, as well as the quantity of water in both the beakers is the same. Then, how will water flow from either beaker 1 to beaker 2 or from beaker 2 to beaker 1? If compared figure 2 with 1, what is the difference? We saw that beaker 2 is raised to a height from the surface as compared to figure 1. So, what makes the difference? When the beaker 2 is raised to a height above the surface, what will happen? Water from beaker 2 will flow to beaker 1. So, what was the factor that triggered water flow from one beaker to the other? The factor over here is height. So, children, again another example we have seen. If you take two bodies touching each other, from where will heat flow? From one body to another? If by chance both the bodies are at equal temperature, will heat flow from one body to the other? No. But if there is difference in temperatures for both the touching bodies, then from where will heat flow? It will be seen that heat always flows from a body at a higher temperature to a body at lower temperature. So the factor over there was the difference in temperatures of both the bodies. Here, the factor that triggered water flow is height. Now, moving on, children, to understand the concept of potential difference. Let's see and observe figure number 3. Over here, we can just see a wire kept. There is no electronic component attached to the wire. So, the question arises, will electric current flow through this wire? I think definitely not. Then, what is the factor that will trigger or cause electric current to flow through this wire? Let's understand it. The factor is potential difference. So first, let's understand what is this potential difference. Now children, we know in simple terms what is potential. What is potential? It is the capability, or you can say it is also the termed as capacity. But in science, we term it as potential energy. We understand what is the concept of potential energy. What is potential energy? As we already know, it is the energy possessed by a body due to its motion. It is the stored energy in that object due to its position. So, energy possessed by an object due to the state of rest is called as potential energy. If I have a ball in my hand, children. What does this ball contain? It possesses potential energy. It has some energy stored in it due to its state of rest, due to its position. That is called as potential energy. If I drop the ball, what happens? The total energy that was stored in the ball gets converted because the ball is in motion. Then what is that type of energy called as? It is called as kinetic energy. So what is kinetic energy? It is the energy possessed by a body or an object due to its movement, due to its motion. So when I drop the ball, the potential energy of the ball gets converted to kinetic energy. Now let's get back to understand what is potential difference. Now children, in science, let's understand the word electric potential. What is electric potential energy? The electric potential energy is termed as the energy stored by any charge in its position. So, what is electric potential energy? It is the energy that is stored in that charge. That is called as electric potential energy. Now, when we had a ball in the hand, the ball had a high potential energy. Similarly, children, electrons, when they are close to each other, they have high potential energy. So, we know electrons are negatively charged. When they are close to each other, they have high potential energy. Now, if they are left free, then what happens? They repel each other. They go away from each other and they get attracted to whom? They get attracted to the positive charge. So, what did we see over here? That when electrons having high potential energy are left free, they get attracted to the positively charged particles. Now children, so let's understand what is electrical potential energy. It is the potential energy possessed by any charge. So let's come back to understand what is potential difference. Now, what is potential difference? It is just the difference between the two electric charges. The difference between the two electric charges due to the electric pressure. Now, if we compare figure 2 with figure 1 in diagram 3, what do we see? The wire has got connected to a cell, or you can say a battery of cells. So what happens when you connect a cell to a wire? There is a difference in the charges that is created when you connect it to a wire. So by definition, we may say that it is, what is potential difference? It is the work done to move a unit charge from one point to the other. Once again and repeat, what is potential difference? Potential difference is the work done by any charge to move from one point to the other. So when this electronic component is attached to the wire, what happens? A difference in the charges is created. And this difference is called as potential difference, which causes or creates electric current to move through it. Now children, if I tell you to weigh the mass of this duster, You might say it is 5 grams. Some might say it is 45 milligrams. So what is the unit of mass that you give me over here? Mass is always measured in grams or milligrams, and if it is heavier, you always measure it in kilograms. Similarly, children, if I tell you what is the length of this duster, what is the breadth, then you might say, you might give the answer in meters or centimeters. For extremely large distances, the unit that you measure distances in is kilometers. Similarly, what is the unit to measure potential difference? The unit to measure potential difference is called as volts. So how is potential difference measured? Potential difference is measured in volts. So children, what did we study here today? We studied what is potential difference. Why potential difference is necessary? It is necessary because it creates electric current to flow through the wire. So children, in the next session or the segment, let's understand what is electricity. We are always aware, children, that light in our homes work on electricity. They are not the only ones. We are not the only ones who we use the electricity. Our televisions, air conditioners, water heaters, fans, laser lights, flashlights also require electricity to function. Imagine a life without electricity. Discovery of electricity has helped our life to be more easier to work with. There is a new redemption in the history of humankind due to the discovery of electricity. Now children, we know there are two basically types of electricity. Which are the two types of electricity? One is static electricity and the other one is dynamic electricity. First type is static and the second type of electricity is dynamic electricity. Let's first understand what is dynamic electricity. Precisely, it implies moving electric charges. What are electric charges? We know that there are two types of electric charges. The two types of electric charges are positive and negative. So, think of magnets, children. We know that when we take two magnets close to each other, what do we observe? When we take two magnets close to each other, we know that magnets contain two poles. One is the north pole, the other the south pole. For any bar magnet or any magnet that you take, right? So one is the north pole, the other is the south pole. Here again, one is the north pole, the other is the south pole. Now when you take two magnets close to each other with opposite poles, what do we see? We see that they attract each other. But in the other case, if two magnets with same poles, north and the other one also with the north pole, are facing each other, are trying to bring close to each other, what do we see? We see that two magnets with like poles always repel each other. So what did we learn in case of magnets? We have learned that unlike poles attract each other and like poles always repel each other. So children, in charges, who exactly carries these charges? They are the subatomic particles. We know the structure of an atom. What does an atom contain? An atom, an atomic structure. In the core, at the center as we call it, it is the nucleus. The nucleus contains, this is called as the nucleus. The nucleus, the core of the atomic structure, the center of the atomic structure contains subatomic particles. Those are the neutrons, which are always neutrally charged, and the protons, the second type of subatomic particles, which are always positively charged. Surrounding the core of the nucleus in the structure of the atom, what do we contain? We contain different orbital shells revolving around the nucleus. What do these orbital shells contain? What do they have embedded in them? They have the electrons. These electrons are always revolving in these shells, or you can also call them as orbits. And what charge do these electrons possess? These electrons possess negative charge. So this shows us the atomic structure. The core is called as the nucleus, which contains the protons and the neutrons. So the nucleus as a whole is always positively charged, and the electrons are always the negatively subatomic particles. And we know the positive charge and the negative charge, they are unlike charges. So like your magnets, unlike charges attract each other, like charges repel each other. And in any atom, whichever electrons are in the outermost shell always are usually used to, or they are the ones who are conductors of electric current. So in next session, children, we will first see how is electric current formed, or what is the factor that triggers electricity to pass through.